Imagine a battery that you never ever have to charge. Not once a day like your phone, not once in a while, not once in a year, not once in 50 years. No cable, no charging pad, no maintenance of any kind. You seal it inside a device, you walk away, and half a century later it is still quietly delivering power, exactly as it did on the first day. It sounds like a fantasy, the kind of thing that shows up in a science fiction film. And yet a company in China says it has already built it, mass-produced it, and made it smaller than a coin you could hold between two fingers. This battery does not run on chemistry, the way every battery you have ever owned does. It runs on something far stranger and far more powerful, a sliver of a radioactive metal and a slice of man-made diamond. Tonight I am going to show you how a so-called nuclear battery, the size of a button, can run for 50 years without a single charge, why it is real, and, remarkably, safe, and the one honest catch that the breathless headlines almost always leave out. Let me start with why every normal battery eventually dies, because it makes the Chinese invention make sense. The battery in your phone, in your car, in your laptop, works through chemistry. Inside it, a chemical reaction pushes electricity out, and over time that reaction wears out. The chemicals degrade, the battery holds less and less, and after a few years it is finished. That is why your phone battery is noticeably worse after 3 years and dead after 10. Chemistry is powerful, but chemistry ages. The Chinese battery sidesteps that entire problem by not using chemistry at all. Instead, it taps into one of the most reliable clocks in the universe: radioactive decay. Here is the beautiful and slightly unsettling idea behind it. Certain materials are radioactive, which means their atoms are slowly, steadily breaking down and releasing tiny particles of energy as they go. And they do this at a rate so predictable, you could set a clock by it. The Chinese company, called Betavolt, takes an incredibly thin sheet of a mildly radioactive metal, a form of nickel, just 2/millionths of a meter thick, and sandwiches it between two slices of diamond. As the nickel slowly decays, it throws off a steady drizzle of tiny particles, and the diamond layers catch those particles and turn them directly into a small, constant trickle of electricity. There is no reaction to wear out, nothing to degrade in the way chemistry degrades. It simply harvests the energy of the metal breaking down, atom by atom, and the metal it uses keeps releasing that energy for about 50 years before it fades. You are not storing energy in this battery. You are slowly, patiently collecting it from the quiet nuclear ticking of a metal that will outlast almost everything you own. And the reason it lasts so specifically, about 50 years, comes down to a property physicists call half-life. Every radioactive material breaks down at its own fixed pace, and the particular form of nickel that Betavolt uses takes roughly 100 years to lose half of its energy. So after 50 years, the battery is still delivering a large share of the power it started with, which is why the company can promise half a century of steady output with a straight face. It is not a guess or a marketing number pulled out of the air. It is written into the physics of the atom itself. The particles the metal releases are a gentle kind called beta particles, which is where this whole family of devices gets its name, beta voltaic. They are weak enough to be stopped by a sheet of foil, which is a big part of why the battery can be made safe. And yet there are just enough of them, ticking out steadily every second, to keep a tiny current flowing for an entire human lifetime. If you want to follow the technologies that quietly redraw what is possible, then subscribe to Sinova, because catching these breakthroughs and explaining them honestly, the promise and the catch, is exactly what this channel is for. Now let me get to the two things that make this genuinely remarkable, and then the catch you absolutely need to hear. The first remarkable thing is the diamond. Turning the particles from radioactive decay into usable electricity is fiendishly hard, and it needs a very special material to do it well. Betavolt says the key to its battery is a man-made diamond semiconductor, and it claims to be the only company in the world that has mastered the technology to produce these diamond components at the size and quality needed. That is not a small boast. Diamond is one of the most difficult and most promising materials in all of electronics, and if China really has cracked how to mass produce it for this, that skill reaches far beyond one little battery. The second remarkable thing is safety. because your instinct is probably screaming the word radioactive right now. But the type of radiation this metal gives off is very weak, easily stopped by a thin layer of shielding, and the company says the finished battery gives off no external radiation at all, remains safe even if it is punctured or shot with a bullet, and is stable enough to be placed inside the human body. In fact, one of its most striking proposed uses is inside medical implants like pacemakers, a device that, today, requires surgery every several years just to replace its dying battery. And that diamond skill is worth dwelling on, because it hints at something far bigger than one little battery. Diamond is not just pretty. As a material for electronics, it is a kind of holy grail, able to handle enormous heat and electrical power that would instantly destroy ordinary silicon, which makes it hugely valuable for the electronics inside electric cars, power grids, and radar systems. A company that has genuinely learned to mass-produce high-quality diamond semiconductors has not merely built a better battery, it has taken a lead in a material that could matter across a whole swathe of advanced technology. The tiny nuclear battery may honestly end up being the least important thing to come out of that particular breakthrough. Sometimes the headline invention is really just the doorway into a much larger room. Now here is the honest catch, and please do not skip it, because it is the single most important fact in this entire video, and it is the part the viral headlines almost always bury. This battery produces a tiny amount of power. We are talking about roughly 100 millionths of a watt. To put that in perspective, that is somewhere around 1/100% of what your smartphone needs to run. Read that again. It is not almost enough to power your phone. It is not a tenth of enough. It is around 1/10,000th of enough. So every headline that screams you will never have to charge your phone again is simply, flatly wrong. This little battery could not run your phone for a single second, let alone 50 years. And anyone who tells you otherwise either did not read past the headline or is hoping you will not. To feel just how small this really is, picture it this way. A normal battery is like a sprinter. It delivers a lot of energy fast, and then it collapses, exhausted, and needs to be recharged. This little nuclear battery is the exact opposite. It is a marathon runner that barely seems to move at all, but that never ever stops, for 50 straight years. It was never designed to be powerful. It was designed to be endless. Trying to judge it by whether it can charge your phone is like being disappointed that a lighthouse cannot sprint. It was built for a completely different purpose, and once you understand that it traded almost all of its power in exchange for almost unlimited endurance, the whole invention suddenly makes perfect sense, and the letdown that it cannot run your phone melts into something much closer to wonder. So if it cannot power a phone, you might reasonably ask, what on earth is the point? And the answer is that there is an entire hidden world of devices that need almost no power, but need it for an incredibly long time, in places where changing a battery is difficult, dangerous, or impossible. Think about a pacemaker buried in someone's chest, or a sensor sealed inside a bridge or a pipeline to watch for cracks for decades, or a probe drifting through deep space far from the sun, or a tiny tracker on a piece of critical equipment. For all of those, a battery that quietly delivers a whisper of power for 50 years, that never needs charging and never needs replacing, is not a gimmick. It is a genuine revolution. Imagine a pacemaker that never requires another surgery to swap the battery, because it will simply outlive the patient. That is the real promise here, and it is a very big deal for the specific places where it fits. Here is the rehook, the thing to hold on to. The story here is not the silly one, the fantasy of a phone you never charge. The real story is quieter and, in its own way, more impressive. A Chinese company took a technology that scientists in many countries have chased for decades, the nuclear battery, and it did the hard, unglamorous thing that actually matters. It moved it out of the laboratory and into mass production. Betavolt calls the BV100 the world's first mass-produced nuclear battery. Not the first prototype, not the first paper, the first one you can actually make by the thousand. And once again, that is the real pattern to watch, not who dreamed of a technology first, but who figured out how to build it at scale first. And the company is not stopping at that whisper of power. Betavolt has said it is working on a version that produces a full watt thousands of times more than the first one, and it points out that many of these tiny batteries can be linked together, stacked in series or in parallel, to add up to more useful amounts of energy. A single watt is still nowhere near enough for a phone, which needs several. But it starts to be enough for a whole new class of small devices, and it shows the direction of travel. The first version is a proof that the thing works and can be built. The next versions are the climb toward power levels that matter for more and more uses. That is how a real technology grows up, one honest step at a time, and China has planted itself firmly at the front of this particular race. So step back and see the shape of it, because it is the same shape we keep finding. This is not the first time someone has built a beta-voltaic battery in a lab. Western and Soviet scientists were experimenting with nuclear batteries decades ago, and some old space probes and pacemakers even used primitive versions. The idea is genuinely old. In the 1970s, thousands of people actually walked around with a sliver of plutonium powering the pacemaker in their chest, and those old nuclear pacemakers ran for decades, some of them reportedly still ticking today, long after the patients who received them. And the great deep space probes, the ones that have now sailed clear out of our solar system, do not run on solar panels at all, because sunlight is far too weak that far out. They run on nuclear power sources, quietly turning radioactive heat into electricity, which is the only reason they can still phone home after nearly 50 years in the dark. So the world has known this trick works for a very long time. What changed is that most of the West quietly set it aside, tangled up in cost, in regulation, and in the public's fear of the word nuclear, and left the whole field half abandoned. What is new is that a Chinese company decided to take that old, half-forgotten idea, solve the brutally hard manufacturing problems, especially around the diamond, and turn it into a real product it can stamp out and sell to the world. The West had the idea. China is building the factory. And in technology, as we have seen again and again, the country that owns the factory usually ends up owning the future of the thing. None of this means you should expect a nuclear battery in your next laptop. And if I told you that, I would be doing exactly what those clickbait headlines do. It is small, it is low power, and it will live, for now, inside pacemakers and sensors and satellites, not inside your pocket. But do not let the honest limits blind you to the honest achievement. In a field the whole world has dabbled in for half a century, China is the one that just reached mass production first, cracked one of the hardest materials in electronics to do it, and started climbing toward higher power. 50 years of power, from a coin, with no charging and no maintenance. It will not run your phone. But it might one day mean that the pacemaker keeping someone alive never needs another operation, and that the sensors watching over our bridges and our borders simply never sleep. If you want to keep watching which of these quiet breakthroughs actually grows into something world-changing, then subscribe to Sinova. And the next time you plug in your phone for the 1000th time this year, spare a thought for the little diamond battery in China that is quietly ticking its way through the next 50 years.